Welcome class to our lesson of today. Yesterday we are looking at integration, and today we are looking at integration. We have a question here. A particle moves in a straight line with a velocity of 3 meters per second. It is velocity after 30 seconds is given by. So we have this velocity which is equivalent to, the velocity here is equivalent to 3t squared minus 6t, then of course minus 9. So we have the figure below is a sketch of the velocity time graph of the curve. So this is velocity, the time graph of the curve, where we have the area in two parts. We have the area under the curve, where we have between 1 and 3. It is the area under the curve, and then we have 3 to 4. It is the area above the curve. So the question, you write now this question here. Calculate the distance of the particle. Calculate the distance of the particle. Calculate the distance of the particle. Calculate the distance. Calculate the distance of the particle. Calculate the distance of the particle. Calculate the distance of the particle. Moves between t is equals to 1, t is equals to 1 second, and t is equals to 4 seconds. So to calculate the distance covered by this particle is just calculating the area, the total area. So we have two areas here, the area under the curve, and then we have the area above that curve. So what did we say yesterday? So if you need to get the distance, we have our velocity. Velocity here is equals to t, 3t squared minus 6t, and then minus what? Minus what? We have this one as minus 9. So how do you get the distance? If you want to get the distance here, you need to do what? What can we do, class? Yeah? What can we do here? Integrate for us to get the distance. So we can integrate now this one here. So our distance now we write, our distance is equal to t. It is now the integral, and we have been given in this case now the limit. The limit is we have t is equals to 1, then we have t is equals to what? T is equals to 4. But we cannot introduce this one at this time. Let us integrate that one first. So we can have this one as it is d, the integral dt. We are integrating this one, which is equivalent to, how can we integrate this? What is it? Can somebody come and integrate this one? Can you integrate that? And then you tell the class what you are doing.
So increase t by,
You face the class when you
gt is increased by 1, and then divided by then minus divided by then this 9 will produce t. So it will be t cubed minus dt squared.
Is it correct?
Yes.
Can you clap for him? So that's how you integrate. We say that when you are integrating, you increase the value of the power of t by 1, then you divide by the new power, and in this case now we have, this is a t squared. If you increase, we can have 3, and therefore our new power becomes what? Becomes 3. Then you divide like that one, you end up getting that the distance is equals to t cubed minus 3t squared minus 9 what? Minus 9t. Now, to get now the distance covered, you are supposed to get the area. There are two areas here. We have the area under the curve, which is between 1 and 3, and then we have the area which is above the curve, which is between 3 and what? 3 and 4. So we can have the first limit. We can have the first limit of the area under the curve by saying that area in this case is equals to P. We have this one as 3 cubed minus 3t squared minus 9t. In this case here now, our limit, the first area, it is between 1 second and 3 seconds. So you can have in this case here, t is equals to 1. Then we have t is equals to what? T is equals to what? T is equals to 3. Now how can you find the area? You substitute when t is equals to, we have t is equals to 3. Now substitute when t is equals to 3 in this area, in this t cubed minus 3t squared minus 9, and give me the answer very fast. Substitute there. Substitute when t is equals to 3. What is t cubed minus 3t squared minus 9t? What is it? What is it? 0. So let us see. So we have this one as what? This is a. This is a 3 raised to 3 minus 3. Then we have 3. This is squared minus 9. Then we have 9. Then we have 3. So what is it? This is giving us. So we have 27 minus 27 minus what? Minus 27. Now what is the answer? What is the answer? So we are negating this one as negative what? Negative 20, negative 27. Now again substitute when t is equals to 1. So this is equals to 1. What is the answer? Somebody come here and try to do that. When it is equals to 1. When it is equals to 1. When it is equals to 1. What is a... Just this thing last and then try to do something.
So we have 1, 2 minus 3, 1 minus 9, 1. So we get 1 power 3, 1 minus, we have 1 square, we have negative 3, and we have 1. So it will become 3 minus 9 times 1, negative 9 times 1 we have. So we have 1 minus 3 minus 9. Get
Is it correct? Yes. Clap for him. So we have this one as negative 11. Now to get the area, we subtract when it is equals to 3. We subtract what we had. We subtract sinimos. T is equals to 3 minus when it is equals to what? T is equals to 1. So we can have this one as minus 27 minus 11. See here? Minus 11. Eh? So we have this one as minus 11, which is equals to P minus 27 plus 11, which is equals to what? Which is equals to what? Minus 16. So we can have this one as minus 16. Of course, we talk of this. And we know that the area will never be a negative. So you ignore this negative, and then you have this one as 16 what? 16 square units. Now, look at this one, and that's this point. Again, now that is now the area under the curve, Sinigo. Are we together, class? Yes. So we have that is the area under the curve. Now we have the area which is above the curve, and the limit is between 3 seconds, and this equals to what? This equals to 4. So we use our the same distance, which is we say now here that area which is equals to t cubed minus 3t squared minus 9t. Now, what is the limit? What is the limit? The limits are 3 to what? So we can have this one as t is equals to 3. Then we have t is equals to what? T is equals to 4. So can you give me when this equals to 3, this equals to 4? What is t cubed minus 3t squared minus 9t? Somebody else? You're going to come. Just come and show us on how we can get this one. When this equals t cubed minus 3t squared minus 9t. When this equals to 4, how can we do this?
So how to find the
They are not getting you what they are not what they are saying.
okay, it's 4 because t is equals to 4, you say this one is t cubed, it is 4, and 3 minus 3 into bracket 4 is 12 into bracket minus 9 4. So 4 cubed to bracket 4 cubed is 64 minus 3 into 4 squared. And then this one minus 6. So when you
Is it okay? Yes. Clap for him. So we substitute when it is equal to that one. Somebody else now come and try when t is equal to 3. When it is equal to 3. When it is equal to 3. Steven, when it is equal to 3, come and substitute there. Now you hear the class. We have this one here. We have t cubed minus 3t squared minus 9t. Now we have t is equal to 3.
minus 3, then 3 is 9 times 3. So 3 cubic is 7, then minus 6 is 9 times 7.
There are some people make minus at the back there.
Minus 7. So
Is it okay? Yes. So we can have this one as negative 7. So to get the total area, I mean the area when it is equals to 4 and it is equals to 3, we subtract. So we can subtract what and what? Minus 20, minus 27, which becomes, which becomes what? Is it positive or negative? Positive what? Positive 7. Square what? We are talking about square unit. Now to get the total the covered particle between this equals to 1 and this equals to 4 is the total area, the area under the curve plus the area above the curve. So the area that was under the curve, you know, when we have this negative, a negative is just showing that the area is under the curve. That is now we we have this negative there. So I said now we can ignore this negative. It's only showing us that the area is under the curve. So this one is equals to P. We can have this as 16 square units. So the total area now is equal to P. We have 16, then plus what? 7. What is 16 plus 7? What is 16 plus 7? 23. And this one now we have this as 23 meters. This is the total distance covered by the particle when this equals to 1 and this equals to what? T is equals to 4. Now you can try this one. You try this assignment. You write, a particle moves along a straight line. A particle moves along a straight line such that it is displacement S. A particle moves along a straight line such that it is displacement S meters from a given point. A particle moves along a straight line such that it is displacement S meters, such that it is displacement S meters from a given point. S meters from a given point. S meters from a given point is given as S is equals to T cubed minus 5 T squared then plus 4, where T is time in seconds. Where T is time in seconds. Where T is time in seconds. Find the displacement of the particle. Find the displacement of the particle. Find the displacement of the particle at T is equals to 5. Find the displacement of the particle at T is equals to P, 5 seconds. Find the displacement of the particle at T is equals to P, 5 seconds. Kindly follow my channel, click the notification bell, you get notified once I upload a new video.